Let's go ahead and look at T3. On T3, we're going to graph a two-variable linear inequality. So we are to plot points on the boundary line, select the line to switch between solid and dotted, select a region to shade it. So our first question says x is greater than or equal to -7. So just as our instructions stated in our notes, we're going to plot our point. So we know -7. We also know that it is solid because of the greater than or equal to sign. And what we're saying is all values of x are larger than -7. Well, we know that would be to the right of -7 because every number that's larger than the number before it goes to the right. Now we have x is greater than -5. So we go and we plot -5. We know that it is going to be a dotted line. So we just, when you're on that point, you won't really see. If you click it again, it just does that. That's not what you want to do. Click it where it is and then go up a little bit, and when you see the black dash lines, then you click and you'll get your dotted line. And it says that x is greater than -5. So every value of x is greater than that. So we want to click to the right. And notice that this arrow is going the same way that we should be clicking. Now, we have here y is less than or equal to -5x. Well, this is starting to look like the slope-intercept form, except this would be what we call I just forgot the name of it. Basically, it's without the intercept. So we know the intercept would be 0, 0. That's what we know. And we want to go down 5. 1, 2, 3, 4, 5. And it's a negative slope, so we know that it's going to fall from left to right. So I'm going to go ahead and put my line there. Again, I'm going to leave it solid because I have y is less than or equal to -5x. Well, in this case, you might want to go ahead and test your point. So y is less than or equal to -5x. We're going to test 0, 0. So I'm going to put a 0 in for y less than or equal to -5 times 0. 0 less than or equal to 0. Is that a true statement? Yes, it's true. So we're going to shade the side that includes 0, 0. Now here's the other question. Well, both sides include 0, 0. Okay, so let's pick another point then. Let's choose point 1, 2. So I'm going to choose, that was -1, +2. So then I have y is less than or equal to -5x. So I'm going to put a 2 in for y. -5 times -1. So 2 less than or equal to, well, -5 times -1 is +5. This is a true statement. So I want to shade the side that includes the point -1, +2. So I'm going to shade on this side. All right, here we go again. So this time we've got y is less than -2x. Well, again, we know we're going to take it through 0, 0 because we don't have a y-intercept that's other than 0, 0. And we know that our line is going to be dotted. So our slope is -2, so we're going to go down 2 and to the right 1 to make our line fall. We're going to make it dotted, and we're going to use the point 0, 0. So y less than -2x. And again, if we choose 0, 0, that might not help us. We've got 0 less than -2 times 0. Now 0 isn't less than 0. 0 is equal to 0. So again, that didn't help. So let's pick a point over here. Why don't we pick 1, 2. So let's test it with ordered pair 1, 2. So we've got y less than -2x. And we've got 2 for y less than -2 times +1. So 2 is less than negative 2 times positive 1 is negative 2. Is this a true statement? No. So we don't shade this side because this is false. We shade the other side. All right, so here we've got something that looks exactly like y equals mx plus b, so we're going to go down to negative 1, and we know again it's a negative slope, meaning it's going to fall from left to right, so we're going to go down 4, 1, 2, 3, 4, and to the right 1. We've got greater than or equal to, so we know our line is solid, and we also know that y is greater than this, so we're going to shade above the line. Now, if you want to test your point, you can use 0, 0. So we've got y is greater than or equal to negative 4x minus 1. We're going to test 0, 0. So I've got 0 is greater than or equal to negative 4 times 0 minus 1. 0 is greater than or equal to negative 4 times 0, 0 minus 1 is negative 1. So is 0 greater than or equal to negative 1? Yes, it is. So we shade the side that includes 0, 0. And if you look at the graph, 0, 0 is right here, and it's in the shaded area. So we know we're correct. Now this says y is greater than negative x minus 1. All right, so our intercept is negative 1. We know our slope is negative, so our line is going to fall from left to right. So we're going to go down 1 and to the right 1. Go up a little bit so that we can make our line dotted because we have a greater than sign. We're saying y is greater than, any value of y is greater than this expression. So we're going to shade to the top. And again, if you want to test it, use 0, 0. So we've got y greater than negative x minus 1. And I'm going to test 0, 0. So I have 0 greater than negative 0 minus 1. 0 greater than, well, 0 minus 1 is negative 1. So is 0 greater than negative 1? Yes, it is. So since this is a true statement, we're going to shade the side that includes the point 0, 0. We'll do a few more. So we've got y is less than or equal to negative x minus 3. Okay, so we know already our y-intercept is negative 3. We know our line is down 1 to the right 1 because we have a negative slope. We know that our line is solid because we have the less than or equal to sign. We also know that all of our values are less than the equation of this line, so that means we have to shade under. Again, if you want to test it, go ahead, use 0, 0. So we have 0 less than or equal to negative 0 minus 3. 0 less than or equal to negative 3. Is that a true statement? No, it's false. So we don't want to shade the portion that includes 0, 0. We shade the opposite side, which we have done, so we know that's correct. So hopefully this was helpful to you. Let's do one more. So we've got y less than x minus 7. Okay, so our y-intercept is negative 7. This time our slope is positive, so our line is going to rise from left to right. We see that our line will be dotted because we don't have an equal sign under our less than sign. It is just less than. So all the values of y are less than this line, which means I'm going to shade underneath. Test it if you must. So we're going to put 0, 0. So we've got 0 less than 0 minus 7. 0 less than negative 7. Is that true? No, that's false. 0 is greater than. So we're not going to shade the side that includes the 0, 0. We're going to shade the opposite side of the line. Oh, I think this one is a good one. Let's do this one, and then I think we'll be done. So we know we have y-intercept of 3. We know this is a negative slope, so our line is going to fall from left to right. We're going to go down 4, 1, 2, 3, 4, and to the right 1. Our line is solid because we have greater than or equal to, and we know all of our solutions will be greater than this line. So our solutions will be above the line. Again, test it if you must. So we have y is greater than or equal to negative 4x plus 3. We're going to test 0, 0. So we have 0 greater than or equal to negative 4 times 0 plus 3. 0 greater than or equal to 3. Is that true? No, that's false. So we don't shade the side that includes 0, 0. We shade the opposite side. Have a good one. I'll see you on T4.